Well, hello, friends. Welcome back to the show. Today, we are going to hunker down and look at a long-standing architectural problem in Serenity, and it is about shared buffers. So, the Serenity kernel has this mechanism called shared buffers, or shbuffs, and they are created with the shbuff create syscall. And a shared buffer is essentially a chunk of memory that multiple processes can map. And it is identified by a shared buffer ID. So you create a shared buffer with a certain size, and then you tell the kernel that some other process is also allowed to use the shared buffer, and then you somehow pass the ID of the shared buffer to the other process, and then that other process can map it into its memory space. And this is sort of the foundation for how we do the windowing system and how the clipboard works and various mechanisms. Now, this is an entirely custom mechanism. It's not the same as any other Unix. So I've long felt that it's kind of it doesn't really fit in, and I would rather have something much more Unixy, like we would pass file descriptors between programs, and we would use mmap to map those file descriptors, and then we could hopefully get rid of the whole custom shared buffer mechanism. So there's a lot of stuff that depends on these shared buffers, and today my plan is to get rid of one of those things that depend on it, and that is the libgui backing store stuff. So every window that you see on screen has a bitmap with all of the pixel contents, and that bitmap is shared between the terminal program here, for example, and the Windows server, and the help program here and the Windows server. So every program that communicates with Windows server uses these shared buffers for the bitmap with the pixels. I'd like to replace that whole thing with something that we can pass as a file descriptor instead of a shared buffer ID, and something that we can mmap in the Windows server instead of using the shbuff APIs. Yeah, so the goal, obviously, long-term goal, is to not have any users of shared buffers anymore, and then that would allow us to remove the feature and remove a large part of kernel code, which I'm not super confident is properly secure. And I think it would make us more of a Unix, so more of a Unix feeling operating system, which I like. So anyway, enough talk. Let's go and build this thing. So the first thing that we're going to need is, since I want to pass file descriptors between GUI programs and the Windows server, I need some kind of file. And I don't really want to create a file in the file system every time that I want to send a bitmap across to the Windows server, because I don't need a file for that. Like, I have no use for a actual directory entry somewhere, right? So I want to have an anonymous file that I can create in the kernel, but it doesn't show up on disk. And all I need really is a file descriptor referring to that file and some memory that can be mmapped if you call mmap on the file descriptor. So let's start by building that. So we'll add a new kernel class. We'll call it anonymous file. And an anonymous file is going to be sort of like the Linux syscall memfd create, but I think we will restrict this a bit more. So this will really just be something that wraps a piece of anonymous memory in a file descriptor so that you can mmap it. It doesn't need any other features than that, at least not right now. So I think we'll invent our own syscall for this particular thing. So we'll call it a non-create, maybe. Okay. Fresh, and let's see how we would write this. So let's start with the syscall, maybe. We'll just have to add it to the list of syscalls first of all. It's been a while since I added a syscall, so I'm a little bit rusty. A non-create. Okay. And then we have to add an implementation function to the process class. So, oh, wait. Is this a non-create? And let's say we take the size of memory that you want and maybe like int options, just like open, so that you could say like oclo exec or something like that if you want this, the return file descriptor to be closed on exec. But I think that's basically sufficient. So we really just want to communicate the size of the memory that we are allocating here. So let's at least start with this and see what we can do. Namespace kernel. All right. And I forgot to include process. And then let's also grab anonymous VM object, maybe. Okay. And then how will this go? So first thing we need to do is allocate a file descriptor. So we can call that new file descriptor. Because if that doesn't work, then you're out of luck, right? You need to have an available file descriptor. This is probably something that's going to cause some trouble later down the line, but we can deal with it then. Because file descriptors are a finite resource, like you can only have so many file descriptors in a process. But for now, let's just plow ahead. Okay, so next thing would be to allocate memory. So we create an anonymous VM object, create with size. And you know what? Let's require that this is that the size is a multiple of the page size, because that's the finest granularity that we can hand out anyway. So let's just say that if size is not like a multiple of the page size, then just return enval. I think that's okay. And then we don't have to deal with goofy sizes. Okay, so create with size. What else does he take? An allocation strategy. Right, so we will say reserve, which means that we will reserve the amount of physical memory needed for this VM object, but we won't necessarily go and figure out exactly which physical memory we're going to be using, because that's not needed yet. We can let the page fault handler deal with that if this is ever paged in. Okay, so if this fails though, because I think that will return a ref footer, yep. So if that fails, that's an eno mem situation. No, not enough memory, dude. Okay, so now we have a VM object with the size, and we want to wrap it in a file descriptor. That's where we are going to need that anonymous file thing. So anonymous file, create with the VM object, but let's see. I guess we have to, yeah, let's write out that class a little bit so that we can see what it would look like. Okay, so here goes, namespace, kernel, and this will be a derived from file, class file. You know what, let's just go and copy paste the inode file class. Then I don't have to remember all of the virtuals we need to override. So instead of inode file, this will be an anonymous file. So anonymous in this case just means that it doesn't have a name, in that it doesn't like show up anywhere in the file system where you would see its name, right? So you can't like ls somewhere and see this because it is anonymous. And of course, instead of taking an inode to be constructed, it will take an anonymous VM object. Cool. And then we can get rid of some of these unnecessary functions. Anonymous file, anonymous VM object. Sure enough. And let's see, so it's not an inode. And let's make this anonymous file class super duper simple. So let's just say can read false, can write false, chmod, no, what do we say, not sup or something like that, right? Not supported. Yeah, we'll just like fail. You can't truncate, chown, chmod, anything, this thing. The absolute path will simply be anonymous file, or you know, some goofy thing like that. This is only relevant in the proc file system, so it's not super important what it says. And for read, will fail, write will fail. But mmap, this is where the good stuff happens. So this is the one that we actually care about. Is it seekable? I mean, let's just say it's not seekable. It's nothing. None of these things. Although I wonder if we can just omit these. Oh, see, the default thing was to return ebadf, bad file. Okay, so I can just not even have these. Boom. What's the default of read? Can read and can write are pure virtual. Okay. Read and write pure virtual. Okay. So we have to have those. But mmap is fine. Is seekable. False by default. Okay, so I didn't even need those. Well, this is nice. It simplifies stuff a lot. Yeah, so we really just need these, and we'll make them all private, actually, so that the public API of anonymous file sort of illustrates how this is meant to actually be used. Only mmap is public, because that's the only thing that it's for. Okay, so now we need a constructor, a destructor, and mmap for this class. So let's see, anonymous file. Namespace, kernel. All right. So the constructor, super straightforward. All right. The destructor, even more straightforward. And finally, oh man, what was the, oh, here we go. Okay. So anonymous file mmap. So this one has a bunch of arguments, and we have to return either a k-result or a region. So basically the way mmap works in Serenity is that when you're mapping a file, then the mmap syscall will locate that file object. So we inherit from file, so we are a file object. It will locate the file object and then call mmap on it with, these are all the different input parameters for the mmap syscall. And will also pass us the process who's trying to map it into its memory space. And that's how we know where to get a mapped memory region from. So I think let's do some sanity checks though. So like we don't want to allow any other offset than 0. Just because that would just complicate things right now. If the size is not the same size as my VM object, so you have to map the whole thing, at least for now. Just because that also simplifies things for us. And then we'll try to map it. So we'll say process, process, okay, allocate region with VM object at the preferred address with the size, with our VM object at offset 0. I don't have a name for it, but I think it doesn't matter. The protection settings and the shared state. Cool. And then if that fails, because that can just return null, right? Yeah. And I think that's also an mem condition. Because if you look at why it would fail, it's that if you can't allocate a range, and a range in this case is a range of virtual memory. So we don't have virtual memory available. Actually, there are some other fail conditions here as well, I see. If you're trying to allocate something that sort of would go outside the VM object range. So maybe it would be even better if allocate region would communicate back like the specific error. But for now, we're just going to say mem. And then at some point, we can go and make this thing return a richer error status. Okay. So then we're good. So we can just return region. Because it succeeded, right? So we allocated a region in the process, and it will be mapped, and it's backed by the VM object that is represented by this anonymous file. So, anon create. Then we need to make a file descriptor. File description, rather. The difference between file description and file descriptor is so subtle. I don't know if anybody actually knows about it unless they've worked on a kernel. But basically a file descriptor, which is what you're used to in userland, it's the integer, like the number that you use when you're communicating with the kernel about your file description. And the file description is a kernel concept which describes a specific file and a offset into the file and some other stuff, like whether it's readable, writable, stuff like that. And file descriptions are kept in a table where the index into the table is the file descriptor. I had no idea about this before I actually sat and read POSIX. And I've tried to use the same terminology in class names and stuff here in the kernel so that it's understandable to somebody who has also read that spec. Description. Okay. Create. So we will create a file description around the file here, the anonymous file. A non-file, let's say. Okay, so if, actually this can fail. So it's a description or an error. So if it is an error, then let's return the error. Otherwise, let's say description or error, release value. And then I guess we should make it, I think we have to say writable and readable, or the mmap will fail at an earlier stage. So that's a little bit weird actually, but ignoring that. Actually, let me verify that I'm right about that. I think mmap checks that kind of stuff. So mmap, mapping a file, validate prot. Here, right, description is readable. Yeah, right, so in order to mmap a file, you have to have read access to the description. And if you're mapping it prot right, then you need write access as well. So it's just a little, yeah, I had a feeling we needed that. So this is a little awkward, but whatever. And then we have the description, we have the file. Now we just need to jam it into the process's file descriptor table, which is MFDs, and that goes into the new FD slot. Let me say set description. Oh, we can just move it actually. Description. Oh, and we need some file descriptor flags. So let's just make those from the options. So like if options and clo exec. Food flags. Food clo exec. Cool. Okay. And then we return the new file descriptor and boom. I think this is right. I guess we can make a little test program to test it. Oh, and we're going to need a syscall for this, actually. I mean, a syscall wrapper in userland. So let's just make one of those. So int anon create size t and options. Something like this. This is our C language API. And it will simply do int rc syscall anon create size options, and then the usual dance to move any errors into error no. Okay. So a test for this would just be something like let's create 1 megabyte of stuff with oclo exec. And if that fails, let's pair. We need Stadio for this. Okay. And let's see, FUD is FUD. Let's try to mmap it. So, then we need sysman. Okay, so we'll map it anywhere. The full size. Prot read, prot write. Map file, map shared. FUD and 0 offset. If that doesn't work, map. Mapped it at, let's say, yeah, okay, so, oh, and then let's go to sleep so we can look at it in the system monitor. Okay, what did I screw up? Anon create. I didn't need pragma once in a CPP file. Keep making that mistake. Okay. All right. looks good. Let's take a look at it here. So we have AF, and it's mapped at 1801. And we see that 1801 right here. It's a little glitchy, keeps unselecting it. That's annoying, but whatever. We have 1 megabyte mapped. It's an anonymous VM object. That's good. So that looks good. It's readable, writable, and shared, just like we wanted. If you look in the open files list, we see that we have an anonymous file open in file descriptor number 3, and it will close on exec. So very, very cool. So this seems good. Let's just commit, I think. I think we're good to commit here. So just adding the anon create syscall and the anonymous file concept. Kernel. Add anonymous file created with sysanon create. Or let's say anonymous files. This patch adds a new anonymous file class, which represents a file backed, which is a file backed by an anonymous VM object that can only be mapped and nothing else, really. This will be useful for passing. This will be, I'm hoping that this can become a replacement for shbuffs. Okay. Yeah, so I think that's good. Now let's try to use these in the windowing system to for window backing stores. So if we go and look at GUI window, every GUI window has a front store and a back store. So it's actually double buffered. We have 2 window backing store objects, and it's really just a simple wrapper class around a bitmap. But basically, we have 2 bitmaps for each window, and you're painting into one of the bitmaps while the other one is on screen. So it's basic double buffering, and both of those bitmaps are backed by share buffers. So now we just need to change the way that we create these bitmaps so that they're backed by anonymous files instead. And then we need to send those anonymous files as descriptors over the IPC connection to the Windows server and map them in on that side using the anonymous file mechanism instead of share buffer mechanism. So I guess here we're using create shared bitmap, and this is a helper function that first creates a shared buffer and then makes a bitmap sort of wrapping that shared buffer. So this is probably used for icons as well as window backing store. So let's not mess with icons right now. Let's just make a new thing. Let's when we create a window backing store, let's do something like this. So wait, what do we really need here? We need the pitch and the size in bytes of the memory that we're allocating, and then we'll say anon file descriptor is anon create size in bytes, and maybe we'll clo exec that because I really dig the clo exec thing. Clo exec. Okay, so if anon fud fails, that's actually a horrendously bad situation, because without a backing store, we can't really fulfill our duties as a GUI program. So in fact, let's just assert not reached at that point. Okay, so previously we would have to first create a shared buffer, and then what you see here is we're explicitly sharing the shared buffer with the server PID, which is the PID of the Windows server. And now that we're going to be passing it as a file descriptor over the IPC wire, the explicit sharing thing here is no longer necessary. So it will be shared just implicitly by virtue of traveling over the IPC socket. So what we want to do now is say auto bitmap is graphics bitmap create with anon fud, let's say. And then we'll just pass in the anon fud. I think actually we have a failure condition here as well, so maybe we should I guess we should fail a bit more gracefully. Okay, so now we need something called graphics bitmap create with anonymous file descriptor. And how should that work? We'll see. So basically it's the same as this one. Create with anon fud. But instead of a pointer to a shared buffer, we just give you the anon fud, and then also the size of the bitmap. And of course, the size of the bitmap informs us of the total amount of memory that will be found behind this anonymous file descriptor. Okay, and then we need, I guess we need a way to get the, wait, do we need to get the anonymous file descriptor from a bitmap? Let's expose it maybe, anon fud. And then we also need a constructor, sort of like this one maybe, int anon fud. And you know, let's skip over the palette modes, because we have like 8-bit indexed palette, 1 to 4-bit indexed palette, stuff like that. But let's only do this for 32-bit bitmaps right now, because that simplifies stuff a bit. And since it's going to be m-mapped, we need to be passing in the pointer. Okay, and maybe we'll just store that there. Okay. So am I using that right? Create with anon fud, you give it the file descriptor, and then this thing will take care to mmap. If mmap fails, it will just return null. Yeah, that should be okay. So, create with shared buffer. Okay. Create with anonymous file descriptor. And what do we need to do there? Well, if the size would overflow multiplication for this bitmap format, then that's very sad. So we will just return null putter. Then we need to mmap. So we'll say, oh, we need to know how much we're going to mmap actually. Data size. Okay, so yeah, so we can just compute that here. So data is mmap, anywhere in memory is fine. And the data size in bytes, prot read, prot write. Might actually be interesting to have read-only bitmaps mapped on the Windows Server side, because there's no need for Windows Server to have write access into these bitmaps. But right now, let's just map them read-write. I'm just taking a mental note of that for the future. And that would be map file, map shared, the anon file descriptor, and 0 offset. Okay, and then if data is map failed, then return null putter. Otherwise, we will return a new bitmap with the anonymous file descriptor and the data and the size. Oof. All right. And then I guess let's copy paste this constructor here a little unceremoniously. And get rid of the palette and instead have data coming in from the outside. We don't have a shared buffer, but we do have an anon food. We don't have a palette, so we'll just say assert not indexed. Assert, assert, assert. We don't have a shared buffer, so we can't do that. Cool. And since we unmapped it, I think we need to set needs unmap true. Outside of that, we should be good. Of course, we've only done the libgui client side of this now. So, and also actually we're not sending it over as a file descriptor to the other side. So let's look at set window backing store. So this is where we actually send the backing store over to the other side. And it's a synchronous IPC message that we send, and it has the bitmaps shared buffer ID. So I guess what we can do here instead is just send over the anonymous file descriptor of the bitmap. And we can actually keep that open. We don't need to close bitmaps, at least not on the client side. I think that's fine. On the Windows server side, since we have so many clients potentially, we're going to have to close the incoming file descriptors, but I think that's okay. Let's see. Let's look at the Windows Server IPC protocol here. So set window backing store. Instead of taking a shared buffer ID, we'll take an IPC file, anon file, and then here in the set window backing store handler, we can no longer use the share buffer ID, obviously. So instead this becomes, or actually we don't need to get a shared buffer. We can just go directly to this bitmap right here. And we use create with anonymous file descriptor. Message, anon file, and file descriptor. I was thinking, should we use file descriptor or take file descriptor? But I think if we use take file descriptor, then the IPC system will no longer automatically close the file descriptor. But in this case, I think we actually want the IPC system to close this file because we don't want to keep it open in the Windows server. So we'll just do this so that we use the file descriptor while creating this bitmap and mapping it. But then it's okay for that file descriptor to get closed because we're not going to keep using it. And what's this? So if last backing store and last backing store shabuf ID is message shabuf ID, then just swap. Okay, so, oh, that's a bit annoying. So until now, we've had this optimization that if you're just swapping between the front and back bitmap in one program, which happens like if you don't resize a window, but you animate something in it, or you're just redrawing, then you're just flipping between the back and front bitmap over and over. And in case you're doing that, then here's how we would detect that that's what you're doing. So we don't need to actually create a new graphics bitmap object. Instead, we can just swap the backing stores because we remembered the last two backing stores that you've sent us in Windows Server. But now this kind of breaks because we don't have like a guaranteed incrementing ID to use as a serial number of the backing store to compare against. Because the file descriptor is not, it's going to be reused and stuff. So how about we just invent a serial number that we do explicitly? Serial, and let's see, how do we make that work? Set backing store. Maybe something like this. Serial is serial, okay, and then yeah, and then we'll just remember those. Okay, and then whoever calls set backing store has to pass in the serial number, which will be in the IPC message, which we have to actually invent or pass along. So we'll just pass it after the anon file. And then we have to do that in the GUI windowing class thingy. So here we need to pass the backing store serial number, which we can just, do something like this. And we will allocate that when you create a new backing store. So maybe like serial, I don't know, like this next backing store serial. This doesn't have to be thread safe or anything, so it doesn't really matter. It just has to be incrementing. Yeah, actually 0 is fine. Last backing store. This reminds me quite a bit of how WebKit manages tiles and stuff when it's doing cross-process tiling. So, okay, we could boot, but we're seeing a lot of crashes. Assertion failed, mbackstore. All right. mbackstore. So these are failing. Windows CPP 359. So create backing store is returning null. Sure. So I guess I don't know why it's failing. So let's slap in some of these assert not reached for now, so we know where we're failing. Um, 735. Okay, so a non-create fails. Oh. Well, I bet it's because we are not rounding the size up to a multiple of the page size. So let's just round up to power of 2 page size, and we should be good. Or maybe we have to do that in here as well. Where we actually do the mmap. Yeah. Okay, I bet that's the problem. So let's try this again. What will fail now? All right, we are crashy. We have not pledged sendfud. Well, that's cool. So we're getting as far as trying to send these file descriptors, but previously we had only pledged, I guess, a shared buffer. But now we need to add a pledge promise. So clipboard history main. Yeah, so if we look at the set of pledge promises here, we see that we have stdio, shared buffer, and so on. And now we need sendfud to actually send file descriptors over to the other side. It's going to be a lot of these to update. Let's see if we can do something like this, maybe. Stdio shared buffer, stdio sendfud shared buffer. Probably a bunch of these that look different, I bet. Yeah, because we haven't been like super consistent with the order of these things, which is kind of annoying now. So I'll just put it next to shared buffer here. Yeah, this is going to be kind of a nuisance to go through all of these and figure out where they need to be added. So let's not do all of them. Instead, you know what, let's just try to build and run and see what happens. Then I'm sure we'll be told that it needs to be fixed in more places, but we can do it then. Crash. Who crashed? Resource graph menu applet. Assertion failed response. Okay, so Windows Server is crashing also. Oh, because Windows Server needs to pledge receive file descriptor, which makes total sense. So here we just need to pledge receive file descriptor because everybody is sending file descriptors to Windows Server, but he is not sending any out. So now that that's cool, we're crashing in clock, file manager. Clock. Wait, what did I just do? Oh, I pledged receive file descriptor. That's not even what I meant to do. Send file descriptor is what I wanted. It's just so many things are crashing that it's kind of difficult to see what's going on. Taskbar. Taskbar is doing a null pointer dereference. Okay. I guess I should actually wait for a stack trace. Okay. Oh, so it's calling shared buffer set volatile in GUI window flip. So that's not going to work because there's no shared buffer. GUI window flip. Calling set volatile. Okay, yeah, so I think in this case we can just call set volatile on the bitmap instead. I think that would just work. Do we have more of these? Shared buffer. Yeah. Maybe that would just work. Well, some stuff is kind of running. Let's see. Audio menu applet. Assertion failed and purgeable. Okay. Same thing in the network menu applet. Bitmap, CPP 431. Okay, so it just always asserts if you call set volatile on something that it has to have purgeable true. Well, I think that this is something we can just set in our new constructor. So we can just say here, where are you? Here, Purgeable is true. So Purgeable, if you're not familiar, is means that the kernel can be allowed to take memory from a process without asking the process first. And by the way, we booted. That's pretty cool. So system monitor does not start. What went wrong? We haven't pledged sendfood. Okay, well, we can fix that. Send food. Oof. All right. Actually, you know what? Let's run system monitor as root so that we can actually look at the Windows Server memory and stuff. So, for example, this terminal right here, we had some trouble. Resizing the window went wrong. Backstore, again, failed. Sure, why? System monitor, create window, 699. Maybe we do need some logging of why it fails here, so let's do something, I guess. Anon create, assert not reached. Let's do something in here as well. So let's pair. Assert not reached. Yeah. Wonder why we were failing, but we'll find out. So resizing. Oh, it only works for a while. And then we crash in Bitmap 196. Here, mmap fails. Okay, sure. Why? Invalid argument. All right. Super helpful, bro. So I guess I will EIN value if you give me the wrong offset or the wrong size. Wrong offset, let's say. Wanted. Wrong size. Okay. So that's kind of weird. What's up with that? So we're creating an anonymous file descriptor, blah, blah, blah. And we're trying to map it, but it has the wrong size. So the anonymous file that we've constructed has a different size than what we are passing in. How did we screw that up? Let's see. Let's just log more stuff, I guess. Created non-fud with rounded size. Rounded to size. Size in bytes. Round up to power of 2. Size in bytes. Page size. Okay. It's very suspicious that it happens after some time, like after we've sent a couple of bitmaps, I guess. So we created rounded to size this, and then we're calling it, we're trying to mmap something that has a different size. How on earth? I wonder what's going on here. Let's log the file descriptor number. Maybe we're like leaking and reusing descriptor numbers or something. Let's see, data size in bytes. Let's log what we are mmapping. So debug line mmapping non-fud with size. Mm-hmm. 24. Wait, in terminal it's file descriptor 24. 52, 52, 53, 53, 55, 56. So it keeps opening more file descriptors. Oh, wait, shit. Are we just never closing these? Yeah, of course. Because why did I think we were closing them? So the Bitmap Destructor needs to close these boys. If a non-fud is not -1, then close it. I think, I feel like that makes sense, because then when you destroy a bitmap that's backed by an anonymous file, it will close the anonymous file. That makes a lot more sense, yeah. Okay. Ooh. Ooh. Cool. And trying to use the browser did not work. Why not, though? What happened here? Trying to close a bitmap in Windows Server. Oh, interesting. And then that fails. Does browser need to be fixed? No. Well, oh, wait, hold on. So these bitmaps that we create in Windows Server, here we are merely borrowing that file descriptor for the duration of mapping it. So we're looking at the anonymous file from the IPC message, the set window backing store message, grabbing the file descriptor, using it to map this memory, but then letting the IPC system close it automatically. So after this point, the bitmap does not own the file descriptor. So really we need a way to communicate that. So we need to say like graphics bitmap like whether it owns the file descriptor or not. Owns anonymous file. No. Or should close. Let's say should close. Well, owns. Owns is better. Because should close sounds like maybe it should close it right away. Although it's, I guess, it's fine to close it right away also. Should close anonymous file. Because then we can just do a takeover and let the bitmap close it. I don't know what I like better. Let's see. Enum class should close anonymous file. No. Yes. Oops. Should close anonymous file. Yeah, and then in the create with an onFD, we just check here. So after we mapped it and it was good, then if should close an onFD is yes, then we just do that. Or we can even do it up here. If it's yes, then close an onFD. Assert that that works out because that should always succeed. And then just forget it like this. And then the bitmap will not try to close it on destruction. Yeah, I feel like that works. And then in libGUI, we need to say here that like graphics bitmap should close anonymous file. No, don't close it. Leave it open because I'm going to be using that file descriptor to send potentially multiple times to the Windows server. Yeah, so I think we're good here. This stuff is a little bit hairy, but I feel like we're making a huge improvement here, though. It's just the real improvement comes when we can remove shared buffers entirely, but even without that, like this whole thing, like using file descriptor passing it and mmap and stuff, it feels like these are sturdier parts of the system, if that makes sense, like tried and true abstractions and so on. So this is good. Opening browser totally works. We can do this and that. Go to Google. Totally loads. Looks a little goofy, but I need to do a browser hacking videos again at some point. That was really open a lot of windows. Text editor crashed. Probably needs to pledge send food. Too many open files. Interesting. So that's not super good. Why do we have too many open files in Windows Server? We should be closing those files. So Windows Server, oh wait, I was supposed to say yes here. That was the whole point. That's why we were not closing them. I said should close anonymous file, no. Right, so that's why we ran out of file descriptors. Okay, and then actually we can't allocate more pseudo terminals. That's why that failed. but we can keep opening GUI programs. And then we need to fix text editor to pledge sendfoot. It's not a big deal. I wonder if hex editor has the same problem. It's just heavily based on text editor. Nope. Okay. But yeah, so we're probably gonna have to go through more GUI apps and like add pledges and stuff. But this is essentially falling into place, I think, which is really cool. Bloop. So let's see how this looks in the system monitor for Windows Server. So we now have a bunch of these unnamed shared anonymous VM objects. These are window backing stores, presumably. And that's pretty neat. And then how does it look for like, so here's the desktop file manager process. We see probably this anonymous VM object right here. And if we look at open files, we see we have two anonymous files open. One for the back buffer, one for the front buffer. That's awesome. And if we look in Windows Server open files, we see that it doesn't have these anonymous files open. So just sockets for talking to the various clients, but we don't keep the files open in the Windows Server side. So that's cool. And then terminal only has one anonymous file open. So if we resize it excessively, while it creates new file descriptors over and over with the new sizes, it doesn't keep them open. So that's working as intended as well. Very, very cool. Okay. So I think this is kind of in a decent shape at this point. So let's commit some stuff. Let's see. Let's do the libgraphics changes first because they are kind of standalone, or like they can stand on their own legs. Yeah. So allow creating a graphics bitmap wrapping an anonymous file, or backed by an anonymous file. Create with anon-fud creates such a bitmap, and also optionally takes ownership of the anon-fud of the file, making sure to close it on destruction. Very, very neat. And then let's see, we don't really need that stuff, so then let's do the libgui changes and Windows Server changes, and then we can do like all of the pledges separately because it's so messy. Right. Oh, this is very tidy, actually. This is it just it feels really quite nice. No obvious problems other than file descriptor starvation. So that's something that we have to address sooner or later with Windows Server anyway, because you know, every client of the Windows Server uses up a file descriptor in the Windows Server for the client socket connection. So I think we're going to need to basically we need a way to increase the limit of file descriptors. That's for sure. Because right now it's like 64 or something like that, which is clearly not enough if you want to run a lot of GUI programs. Anyway, libgui plus Windows Server. Use anonymous files for window backing stores. This patch replaces the use of shbuffs for GUI window backing stores with the new anonymous files mechanism. To support the cached bitmap swapping optimization, the Windows Server side, each backing store is assigned an incrementing serial number on the client side, and if we've this allows us to reuse an already mapped file. Backing bitmaps are now on top of, or wrappers around memory allocated with an on create. Are now sitting built on something. They are passed across the IPC socket as IPC file. This means that Windows Server now pledges receive file descriptor, and graphical clients need to pledge sendfd to keep working. Cool. And then we have all of these sendfd pledges. Pledge sendfd in Windows Server client programs. This is needed for the new way we pass backing. We transfer window backing stores. Awesome. Okay. So it works, I think. This app is cool, by the way. It shows you the space utilization of the disk, like what files are the biggest. Anyway, I think that's going to be it for today's video. So I'm very happy with this progress. So if you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting here, and I think going forward, this is going to be, it seems pretty straightforward what we need to do. We just, there's probably going to be some small things that share buffers can do that we need to come up with ways for anonymous files to do, but we'll get there. Anyways, thanks for watching, and I'll see you next time. Bye.